The second correct that goes before 3.4 is 3.4b, and it's finding the least common denominator. So we don't get too in-depth because we're not going to actually add or subtract rational expressions, but we do want to find the least common denominator because it will be helping us in 3.4 when we try to solve rational equations. So it just says when the denominators of two fractions are the same, the fractions can be quickly added or subtracted. But when the fractions don't have the same denominator, however, both fractions must be modified so they can have the identical denominators. I'm going to kind of skip these steps and I'm just going to go right to it, okay? So how I find my LCD, with numbers it's not so bad. So the LCD means least common denominator. It means it's the smallest number that both denominators go into. So over here, I just do the prime factorization of each. What is 8 when it's broken down into primes?
8?
Yeah. When if you did a factor tree, how would you break 8 down? What are any two numbers that multiply to be 8?
2 and 4.
And then how do you break 4 down?
2 and 2.
2 and 2, right? So it'd just be 3 2s. Do we agree with that?
So just 2 cubed.
2 cubed, you got it. What's the prime factorization for 12?
Like 2 and 3.
4 and 3, but then 4 breaks down to 2 and 2. So this would be 2 times 2 times 3. So you guys, especially since there's only a couple of you in here, you can look at 8 and 12 and say, okay, what's the smallest number that both 8 and 12 go into? 24. Okay, that's what we're trying to get to. But I'm showing you this method where after you break down your denominators, to find your LCD, you take everything in the first denominator. So what does 8 need? It needs 3 2s. Okay, so our LCD needs an 8 for sure. Then you go to the second denominator and say, what does he need? He needs a 2, but we already have it. And what does he need? He needs a second 2, but we already have it. What's he need? A 3. Do we have a 3? No, so we'll add it on. And that will get you the smallest number that both numbers go into. So what's 2 times 2 times 2? That was 8. And then 8 times 3 is what? 24. There's your LCD. Okay, and the reason why I do it this way is because it's going to make sense when we get to denominators that aren't numbers, denominators that are polynomials. What we're going to do is we're going to factor them all off to the side, and then we'll bring all the factors together to make the LCD not repeating any factors that they share. They can share factors. Okay, so we're going to do the same thing over here. So 4y to the 5th, how does 4 split up? 2 and 2. And then the long way, how does y to the 5th split up? 5 y's. I'm only going to do it once like this, and then I'll tell you the shortcut, okay? So then how does 8y split up? Well, we already know 8 splits up with 3 2's, and then he needs 1y. Is that okay? So when we go over here to do the LCD, what do we need? We need 2 2's for 4, and we need 5 y's. There's my 4y squared, correct? And then you go to 8, he needs a 2, got it. You go to 8, he needs a 2, got it. He needs a third 2, do we have that? No. So we're going to add it. And then what about a y? Do we need to add a y? No, we have plenty of them, right? So our LCD ends up being 2 times 2 times 2, or 8, y to the 5th. And again, you guys could do probably that one without doing all this, where like, oh, I'm off to the side, sorry. Where, what's the smallest number that 4 and 8 go into? 8. And then what's the smallest variable or power of y that y to the 5th and y go into? Y to the 5th, okay? So for your least common denominator, the highest power of your y is always going to be your part, okay? Let's go down to 3. How do we split 6y up? Well, how do you split 6 up, guys?
2 and 3.
2 times 3, and then who needs to be behind it? A y. And then how are we going to factor 4y plus 12? What can we factor out of him?
4.
A 4. But what is a 4 really?
2.
A 2 times 2. Is that okay? So when I go to build my LCD, I'm going to start with my first denominator. My first denominator needs to be represented. 2 times 3 times y. 2 times 3 times y. There's 6y. He's represented. And then I go to my second denominator. What's he need? A 2. Got it. What's he need? A second 2. I don't have it, so I need to add that. And what else does he need? The y plus 3. So the whole idea of a least common denominator is both denominators need to be hidden in there somewhere. So that's why I always start with the first one. Like the first one has to be represented, so just start with the first one and then add any things you need to. So when it's all said and done, we're going to have 2 times 3, which is 6. 6 times 2 is 12. Y times y plus 3. And again, you don't see that right off the bat when it's just left as 6y and 4y plus 12. So it's best to factor all of them first and go from there. Are there any questions on that so far? You guys see what I'm doing? So I'm breaking each denominator down to primes as much as possible. Then I'm starting with the first denominator. So like this one was 6y. I needed 2 times 3 and a y. And then I move on to the second denominator and I add any guy that is missing. So when I moved on to the second denominator, he was missing a 2, so I added an additional 2. And then he was missing a y plus 3. Is that okay? Any questions? All right. So 6y, 4y, I feel like we're back to easy ones. 6y we already did. That was 2 times 3 times y. 4y is what? 2 times 2 times y, right? So when we go to do the LCD, start with the first denominator. 2 times 3 times y. Then move to the second denominator. What's he need? A 2. I have it, but he needs a second 2, so I need to add it. And he needs a y. I have it. So what's your LCD end up being? 2 times 3 is 6. 6 times 2 is 12. So 12y. And that's one, again, that you can probably visually see. What number do both 6 and 4 go into? 12. And how many y's do you need? Just one y. It would represent each of those denominators. All right. Here, this is kind of starting getting weird. What does x minus 2 need? He needs x minus 2, but I'm going to put him in parentheses so I know that he goes together. What does x plus 5 need? He needs x plus 5, but I'm going to put him in parentheses so we know it's together, so they're not sharing an x, right? So what's my LCD need? He needs the first denominator, x minus 2. What else do we need? The second denominator, x plus 5. So this is just a case of two denominators that don't share any common factors. So the LCD is just a product of the two. So like say you had 3 and 5. You're like, well, 3 and 5 don't share anything. So 3 times 5, 15 would be the LCD. Are there any questions on that guy? So we're just going to keep factoring these things. All right, over here to the right, 7x minus 14. How can you factor him?
Take out 7.
Take out a 7. What will be left behind him?
X minus 2.
X minus 2. All right, x minus 2, the quantity squared. How does he factor? X minus 2 times x minus 2. Perfect. All right, so I'm going to go to my LCD and say, okay, what do I need for my LCD? Well, for the first denominator, I needed a 7 and an x minus 2. And when I go to my second denominator, what did I need? X minus 2. Got it. But what else do I need? A second x minus 2. So you can leave it like this, and I typically do. Or what's another way we can write that? X minus 2 quantity squared. And do you guys agree that that LCD would represent both? Here's the first denominator, 7 times x minus 2. Here's the second one, x minus 2 squared. All right, last one. I think this is kind of like the typical ones, like if you were taking Math 116 that you would see. So for purposes of the class, just to save time, I'm going to tell you what these two denominators factor to. So factors of 3 that add to 4 are 1 and 3. So using the AC method, I'm going to write that down. We're using the AC method, but I'm not actually doing it. This factors to x plus 1, x plus 3. Okay? And the second one, factors of 21 that add up to 10 are 3 and 7. So this factors to x plus 3, x plus 7. So when I go to build my LCD, I'm going to do like what I've been doing. I take my factors for my first denominator, which were x plus 1, x plus 3, okay? And then I move on to my second one. What's he need? An x plus 3. Got it. So what else do we need? An x plus 7. And again, the whole idea there is that you didn't have any repeating factors that were unnecessary. There's my first denominator, x plus 1 times x plus 3. There's my second denominator, x plus 3 times x plus 7. So this is the ugly common denominator.